Hi students, welcome to another classes. Today we will discuss some important reagents in organic chemistry, that is the halogen in presence of base, that is the haloform test. Haloform test. This is the very important test in organic chemistry. So how to identify the given equation, this is the haloform test or not. So based on reagents and reactants and products, easily identify this is a haloform test or not. Okay students. Reagents. What are reagents involved in this reaction? What are reagents involved in these reactions? Halogens and bases are involved in these reactions. Reagents. So Cl2, Br2, Cl2 plus base and Br2 plus base, Br2 plus base and I2 plus base. Very shortcut forms NaX, NaX OX minus or OCl minus and next OI minus, OI minus. These are reagents. One more important reagent is chloro, that is the bleaching powder in presence of water that convert to CaClOH twice, CaOH twice plus Cl2. This is also haloform reagent. So this reagent used in haloform test. These reagents are used in haloform test. These reagents are used in haloform test. So what are reactants? Which reactants are involved in this reaction? Which reactants are involved in these reactions? So alcohols, aldehydes and ketones are involved in these reactions. Alcohols, aldehydes, ketones are involved in these reactions. Alcohols, aldehydes, ketones are involved in these reactions. Alcohols, aldehydes, ketones are involved in these reactions. So which alcohols are involved in these reactions? Primary alcohols, secondary alcohols involved in these reactions. Which primary alcohol is involved in this reaction? Which primary alcohol is involved in this reaction? Only ethyl alcohol is involved in this reaction. Only ethyl alcohol involved in this reaction. This type of group is required to involvement of these reactions, in these reactions. So where this group is present in alcohol, that alcohol is involved in haloform reaction. So methyl alcohol does not involve in reaction. Why? Because this type of group is absent here. And benzyl alcohol not involved in this reaction. Benzyl alcohol not involved in this reaction. Phenols are not involved in this reaction. Why? Because the type of group is absent in these compounds. Any primary alcohol except ethyl alcohol does not involve in this reaction. This is the primary alcohol not involved in reaction. This is the primary alcohol not involved in haloform test. In primary alcohol, only ethyl alcohol involved in this reaction. Only ethyl alcohol involved in this reaction. No other alcohols involved in this reaction. Primary alcohols. In primary alcohol, only ethyl alcohol involved in these reactions. So next, secondary alcohols. Which type of secondary alcohols are involved in these reactions? CH3, CH, OH, and in place of hydrogen, any alkyl group is there that are involved in haloform test. This type of group is present in secondary alcohols that are involved in haloform test. For example, so this is involved in haloform test. Why? Because CH3, CHOH. So this is also involved in haloform test. This is also involved in Haloform test. This is also involved in Haloform test. 2-propanol, 2-butanol, 2-pentanol, 2-hexanol, 2-heptanol involved in Haloform test. Haloform test. Next C6H5, C6H5, CH, OH, CH3. This is also involved in Haloform test. Why? Because this is the secondary alcohol and also have CH3, CHOH group. And next C6H5, CHOH and C6H5. This is not involved in Haloform test. Why? Because this group is absent in this. So next, so this is not involved in Haloform test. Why? Because they are not, this compound not contain this type of group. This type of group not present in this alcohols. This alcohols. 2 holes are involved in Haloform test. 2 holes are only involved in Haloform test. So which here primary bits based on Haloform test, which of the following give positive test for Haloform test, which of the following does not give positive test for Haloform test. This is give positive test, this is the negative test, this is also negative test, this is also negative test. This alcohols does not give Haloform test. In primary alcohol, no doubt, in primary alcohol, only ethyl alcohol involved in Haloform test. Only ethyl alcohol involved in Haloform test. That is a very, very important, students. So next, in aldehydes, only acetaldehyde involved in this reaction. Only acetaldehyde involved in this reaction. Only acetaldehyde. Other aldehydes not involved in this reactions. So formaldehyde does not involve in this reaction, and benzaldehyde does not involve in this reaction, and any other aldehydes not involved in this reaction. Why? Because here required group is in aldehydes. A required group is CH3 CH double bond O. This is the required group. So this group only present in acetaldehyde. Acetaldehyde in primary alcohol, ethyl alcohol. Ethyl alcohol oxidation to give acetaldehyde. So ethyl alcohol involved in Haloform test, acetaldehyde involved in Haloform test. Other alcohols not involved in, other primary alcohols not involved in Haloform test. Other aldehydes not involved in Haloform test. Only acetaldehyde involved in Haloform test. Only acetaldehyde involved in Haloform test. So other aldehydes not involved in Haloform test. Other aldehydes not involved in Haloform test except acetaldehyde. The remaining all aldehydes not involved in Haloform test does not give positive test for Haloform reaction. In ketones, two ketones, secondary alcohols oxidation to give ketones. Secondary alcohols oxidation to give ketones. So this type of group is required to involvement of ketones in this reaction. CH3 C double bond O, CH3 C double bond OH, CH3 C double bond O. H in aldehyde, CH3CO group. CH3CO group is very, very important group. CH3CO group is very, very important group. So required, this is the required minimum requirement involvement of Haloform test. CH3CO group. So which type of ketones involved in Haloform test? 2 ketones, 2-propanone, 2-butanone, 2-pentanone, 2-hexanone. This type of compounds are involved in Haloform test. 2-pentanone, 2-hexanone. So whatever it may be the group here, so anyway more bulky group, but that is present in second position, that is involved in Haloform test. This is involved in Haloform test. So this is involved in Haloform test C6H5, C6H5, C double bond O, CH3CO group is there. So this is involved in Haloform test C6H5, C6H5. Benzophenone involved in Haloform test? No. So this is involved in Haloform test. So no. So your primary task is in this test. Which are the following involved in Haloform test? Which are the following give positive test? Positive Haloform test. Positive Haloform test. So which compounds involved in Haloform test, students? Primary alcohols, secondary alcohols, and aldehydes, ketones. Aldehydes and ketones. So which primary alcohol involved in Haloform test? Only ethyl alcohol involved in Haloform test. Only ethyl alcohol involved in Haloform test. In secondary alcohols, 2 ols, 2 propanol, 2 butanol, 2 pentanol, 2 hexanol. This type of alcohols involved in Haloform test. This type of alcohols. This group in R is whatever it may be the R. This group is there that is involved in Haloform test. So here any bulky group is there that compounds are involved in Haloform test. So which are involved in Haloform test, which are not involved in Haloform test, that is the very important. Here reagents are important. What are reagents, students? Halogens by base. Halogens by base are halite, hypohalite ions. Hypohalite ion. Hypohalite ion. Hypohalite ion. That is the very important, students. So next, for example, IO minus is given. Ethyl alcohol is given. Ethyl alcohol. Ethyl alcohol, IOI minus. What is the reaction? This is the Haloform reaction. This is a Haloform reaction. This is a Haloform reaction. Okay, students. So first, alcohol involve react with halogen, that is convert to aldehyde. First aldehyde, acetaldehyde. Alcohols are oxidized to aldehydes. All primary alcohols are oxidized to aldehydes. Ethyl alcohol convert to acetaldehyde. Ethanol convert to ethanol. This is the oxidation reaction. This is the oxidation reaction to remove the hydrogens. Dehydrogenation or oxidation reaction. So next, this is involved in halogenation. Halogenation, here hydrogens are removed. So CI3, C double bond OH plus 3HI. Here 3 molecules of iodine is required. Here 1 molecule, here 3 molecules. So next, this is involved in hydrolysis. So that is breakage of bond, NaOH or KOH. Here Na is not given, here salt is formed. How to break this? Break here add H. Here remaining part is added to this part. So CHI3 plus here product how to identify, students? Here H R group. H is there, H, R is there, R. Here C6H5 is there, C6H5. What is the byproduct here? Byproduct also very important. Byproduct H C double bond O, HC double bond O, O Na. Here Na is not given, ion is there. So followed by acidic hydrolysis. To form acid. What is the acid, students? Formic acid. Followed by acidic hydrolysis, that byproduct convert to acids. So this is the Haloform reaction. This is the Haloform reaction. In Haloform reaction, what are products, students? Haloforms are products. So a iodoform reaction is a very important reaction. Why? Because a iodoform color is yellow color. Color of the iodoform, yellow color crystals are formed. This is the solid. Yellow color crystals are formed in this reaction. So 1 mole of iodoform is formed from 1 mole of ethyl alcohol. How many halogen molecules are, how many moles of halogens are required? 4 moles of halogens are required in this reaction. That is the very important bit. So first step is oxidation, next step is halogenation. Also this is sometime oxidation reaction. Final step is hydrolysis process. Final step is hydrolysis process. So one more important equation. For example, directly take the aldehydes or ketones. No need the first step. We are not involved in first step. So take the ketones. So here whatever it may be the group present in byproduct in the end of the reaction. So first react with halogen, that is convert to Ci3 plus Ci3 double bond O, C double bond O, and this group. So 1, 2, 3, 4, 5, 6. So after that hydrolysis, NaOH or KOH or CaOH twice. For example, CaOH twice. So break here. So H is added to here. This is involved 2 moles. Here 2 moles. Here also 2 moles. 2CHI3 plus. So this total part. So 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. So C double bond O. So 1, 2, 3, 4, 5, 6. And C double bond O twice Ca. Here valence is 2. This is the byproduct. So followed by delta, these are convert to ketones. This byproduct is convert to ketones. So how to write the ketones? In organic chemistry, what is the use of reagent at that reactions? That is the very important. So here, so 1, 2, 3, 4, 5, 6, C double bond O. 1, 2, 3, 4, 5, 6, 7 carbons are there here. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So O. So a breakage of CaCO3 to convert to ketones. Here C double bond O in both carbons. So distillation followed by delta to convert to ketones. The byproduct also very important here. Byproduct also very important. So this is the Haloform test. Aldehydes and ketones directly involved in second process. Take the alcohols. Alcohols first oxidize, convert to aldehydes and ketones. Aldehydes and ketones again involve in halogenation. Next involve in hydrolysis. Involve in hydrolysis to form haloforms and one byproduct here. Byproduct is very important. Byproduct is very important. So next, here very important one example is there. So this is the very important sweats. C double bond O. So this is the 2-butanone. 2-butanone react with IO minus. The 2-butanone react with KMnO4 in presence of acidic medium at very high temperature. Very high temperature. So this is the haloform reagent, this is the oxidizing agent, this is the oxidizing agent. In presence of KMnO4 at very high temperature, normally does not react with KMnO4 ketones, very less reactive, but at very high temperature, so involve in breakage of bonds, the breakage of bonds here. So which rule students? That is the pop-up rules. So what is the pop-up rule? According to pop-up rule, so break here CO group given to least number of carbons. So this carbon is oxidized to convert to COOH. So this carbon also oxidized to convert to this carbon is convert to COOH. 2 moles of acetic acids are formed. So here break here first convert to tri halogenated compound. After that break the compound, that is convert to CHI3 plus CH3 CH2 C double bond O minus. Yes, Na is there, Na. That is hydrolyzed. So followed by acidic hydrolysis, that is convert to propanoic acid. That is convert to propanoic acid. Here major product is propanoic acid, here major product ethanoic acid. What are reagents are required? For example, so here butanoic acid is formed followed by hydrolysis, final product. So in this case acetic acid plus propanoic acid is formed. So which reagents are suitable in both cases? So here which reagent is suitable is here break here. So haloform reagent is suitable here. So OI minus or halogen by I2, halogens by base, halogen by I2 by base, Cl2 by base, Br2 by base. So here which rule is here? Breakage is here. Why? Because here 2 carbons, here 3 carbons are there. Here 4 carbons, here only 1 carbon. Breakage here take place. So here important reagent KMnO4 in acidic medium or K2Cr2O7 acidic medium, very high temperature is required. That rule is called as pop-up rules. So products are given. What are reagents are suitable reagents in these reactions? So in this reaction, which reagent is suitable? Halogens by base. In this reaction, KMnO4 or K2Cr2O7. at very high temperature. This rule is Popup's rule. This is the Haloform test. This is Haloform test. So halogens by base used in Haloform test. Another important is there, that is the Hoffman bromide degradation test. Another test is Hoffman bromide degradation test. So this is the very important. Amides convert to in presence of Br2 by base. Amides convert to here. Amides are convert to RC double bond. That is convert to primary amines. That are convert to primary amines. Remove the CO group. That's why this is the degradation reaction. Hoffman bromide degradation. Here Br2 by base. Br2 by base used in only two reactions. One is the Hoffman bromide degradation. Another one is Haloform test. So in these reactions, amines are formed. Amides are converted to amines. So here CO is removed as CO3 minus 2 in form of carbonates. So in this reaction, what is the mechanism? RC double bond O, NH2 involve in react with Br2 to form RC double bond O, NH, Br and HBr plus HBr. So this is react with K plus or Na plus, so and OH minus. First react with OH minus, that is remove the H plus, so that is C double bond O N Br. So after that is react with Na plus to convert to RC double bond O N. This is the nitrene. So nitrene is very less stable, that is involved in rearrangements. So CN double bond C double bond O, isocyanates, followed by hydrolysis, that is convert to R NH2 plus CO3. Here come that is involvement with base to convert to Na to CO3. So Br2 by base used in only two reactions in organic chemistry. So Cl2 by base in Haloform test. So here only suitable Br2 is suitable here. So this is the Haloform test and Hoffman bromide test. This is the very important in organic chemistry, students. Thank you very much, students.